What is readers and writers problem? The readers-writers problem is a classical problem of process synchronization. It relates to a dataset such as a file that is shared between more than one process at a time. The readers-writers problem is used for managing synchronization among various readers and writers process so that there are no problem with the datasets. Before we solve the problem, we need to know what is readers and what is writers. So readers only read the dataset and they do not perform any updates, while writers can do both read and write in the dataset. Writers and readers cannot access the object at the same time. And also, multiple writers cannot access the object at the same time. However, multiple readers can access the object at the same time. How to solve this problem? Well, it can be solved by two ways, which is mutex lock or semaphore. What is mutex locks? Mutex is a mutual exclusion object that synchronizes access to a resource. It is created with a unique name at the start of a program. The mutex locking mechanism ensures only one thread can acquire the mutex and enter the critical section. This thread only releases the mutex when it exits in the critical section. Advantages of mutex lock. Mutex is just simple locks obtained before entering its critical section and then releasing it. Since only one thread is in its critical section at any given time, there are no race conditions and data always remain consistent. Disadvantages of mutex lock. If a thread obtains a lock and goes to sleep or is preempted, then the other thread may not move forward. This may lead to starvation. Only one thread should be allowed in the critical section at a time. The normal implementation may lead to a busy waiting state which wasted CPU time. This is a suitable analogy example to demonstrate the mutex lock method. The kids will represent the method and they has to wait and is queued up by the system till the mutex object is unlocked. After the previous object is unlocked, the object behind it can enter. This method will repeat and goes on and on and on. Next, what is semaphore? Semaphore is simply a variable that is non-negative and shared between threads. A semaphore is a signaling mechanism and another thread can signal a thread that is awaiting on a semaphore. It allows more than one thread to access the critical section. They allow flexible management of resources. Semaphore programming is a complex method, so there are chances of not achieving mutual exclusion. A hospital receptionist counter can indeed be a suitable analogy for explaining semaphore. In a hospital, there are often multiple counters or desks where patients can register, check in, or seek assistance. The queuing system at the hospital counter acts as a semaphore, and it controls access to the limited resources by allowing limited number of patients to approach the counter at any given time. So for example, there is a full capacity of patient and the doctor said, "Sorry, it's full. Please wait in line." So the others needs to wait until it's available to enter. When a patient leaves, then it's available for the next patient to enter. The hospital counter analogy captures the essence of semaphore, including acquiring permissions, limiting access to limited resources, signaling availability, and orderly coordination of patient interaction. Both semaphore and mutex locks play vital roles in concurrent programming and operating systems, enabling efficient resources sharing, preventing race condition, and ensuring synchronization among multiple entities. Thank you all for watching. This video is specially presented by Shah Aiman. For more, please like and subscribe.